Alright, so we're going to do a little review for the final. Let's start with this one. Find the domain and range of the following. Right, when I'm inside the radical, is that going to move me left and right or up and down? Do what? Right, left and right. You do the opposite. So if you had a normal grid here, you're actually going to, this means you're going to do right 6. And then this is just like the shape. This is the hill graph. So find me the domain and range of that. All right, your domain is your x values. So x is going to be greater than what? 6. Excellent. Okay, so that's for the domain and range. So the domain will be x is greater than or equal to 6. And then my range, think about my range is the y value. So I'm going to start at 0 and go up. So y is greater than or equal to 0. Right, number 2. Given this function x squared plus 4x, and that g of x is x plus 4. We did a little bit of this, but what operation does this actually mean? Divide. Excellent. You want the f divided by g. So I want x squared plus 4x divided by x plus 4. Do my 4's cancel right here? No. Okay, you want to try to cancel, but you're not going to be able to cancel until you do some simplification. You can't simplify x plus 4. The denominator won't simplify. Can you simplify the numerator? Yeah. Right. What can I take out of the numerator? An x. If I take an x out of here, I'm left with an x. If I divide this by x, I'm left with a 4. And then an x plus 4 on bottom. Now what can cancel? Yeah. Good job. This quantity of x plus 4 divided with this quantity of x plus 4. Giving me x is my answer. Okay, if I'm solving a problem you didn't know how to do, you might add it to your note card or add a little tip. Okay? Find 2 coterminal angles, one positive and one negative with 68. How do we find a coterminal angle? What do we do? We add 360. This would be 68 plus 360 and 68 minus 360. So you end up with 428 degrees is your positive coterminal, and your negative is negative 292 degrees is your negative coterminal. Number 4, you actually need a unit circle. Okay, so you either need to know how to build a unit circle for this problem, or it needs to be on your note card, something. Look and see if you could solve this on your own. Try it. Right? If you look at cosine at 5 pi over 6, so first you got to find 5 pi over 6. I'm here. Cosine is the x or the y value? X. Excellent. So it's this spot right here. This negative root 3 over 2. Number 5. Find the value for x, and this time, look here. What's it in? Radians. So put your calculator in radians. Go to degree, find your mode, and hit radians. Now let's solve the problem. You're going to subtract 3 from both sides first. So now you've got negative 2 tangent of x equaling 5. Divide both sides by negative 2. So now tangent of x equals negative 5 over 2. You can put the negative wherever you want, as long as the fraction is negative. So remember how to solve this? Very good. You have to find the inverse. So you're actually going to say, okay, tangent of a negative inverse of negative 5 halves equals the missing x. Type this in your calculator. And x actually gave me what? What did it give you? Did you got negative 1.19? Okay. Are we allowed, and my guess is that its choice is probably there, and it's wrong. Because remember, it wants between 0 and 2 pi. That's a negative answer. Okay? This is tangent. So let's build ourselves a little graph. And I wanted a negative tangent. Look at your unit circle. When is tangent negative? Tangent is the one that draws the straight line rather than the V. Okay? Now, it gave me this. It told me that, oh, I shaded that wrong. It told me the highlighted section is 1.19. The problem is it's a negative, right? To get from here to here, it's negative 1.19. So we're going to go from here and find this measurement. But because I know it's radians, this is no longer, remember we used to use 180, but now we're going to use 3.14 and 6.28 on this problem. So to get to here, I would go all the way to 3.14 and I'd back up that shaded region. That shaded region is 1.19. So to get my first answer, I'm actually going to take, I'm going to put it over here, 3.14 minus 1.19. Which gives me 1.95, is that what you got? That's one of your answers. Now on the other answer, you're going to start here and go all the way to the second line. But instead of taking 360 minus the 1.19, we're going to do 6.28 minus your 1.19, giving us 5.09. Would y'all like me to do another problem like 6? Okay, I tell you what, I'll give you 1 minute to set up 6, see what you can do. It's in degrees, so change your calculator back to degrees for problem 6. Right, so your calculator should be in degrees. So your first step would be to divide, you're trying to solve for sine of theta, you're trying to get this all alone, so divide both sides by 3. So now sine of theta is 1/3. In your calculator, you're going to take the inverse of 1/3. That's going to be theta for you. And I got 19.47 for theta. Now if you draw a picture, I'm looking for sine to be positive. I want y to be positive. On the y-axis, if I'm positive, I'm here and here. Well, I just gave you this angle. It's 19. It's positive. We're good. We're going to be looking for this one. So this angle is 19.47. My job is to find the other angle, to go from here all the way to here. How am I going to find that? Am I going to use 180 or 260? 180. Good. I know if I went from here all the way to here, I'd be 180. I'm going to back up the yellow region. The yellow region is 19. So this would be 180 minus 19.47 degrees. So your other angle then would be 160.53. We're going to skip 7, move to 8. Okay, 8 is one that you have to use your unit circle for. So if you don't have a unit circle, go ahead and take it out. Okay, first of all, I'm talking about a restriction. So my restrictions for cosine are here and here. These are all of them if you didn't know them. But that means that if there's a -1 there, an inverse, I'm only allowed in these quadrants. So cosine is in quadrant 1 and 2. So I'm going to be looking for a 1/2 as a cosine value in these two quadrants. Here's my two quadrants. Cosine is here, 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 and here, here, here. The only positive one is this spot. I gave you an outside value, so what are you going to give me? Inside, you're going to give me pi over 3. So then, okay, now then I'm looking for tangent of pi over 3. Let's find it. Tangent pi over 3. Is there a restriction on tangent pi over 3? No, there's no negatives. I go anywhere I want. So here's pi over 3. There's cosine, there's sine, and there's tangent. So the answer is root 3. Okay, number 9. This time, what does your calculator need to be in? Radians, right? Because of this, you're going to put your calculator in degrees radians. To solve, I'm going to subtract 4 first. And then we divide by what? What are we going to divide by? -3. So secant of x equals -8/3. Where you put the negative doesn't matter. In front of the 8, in front of the 3. But is secant in my calculator? No, so we're going to flip secant to. Right, cosine of x now equals -3/8. I'm running out of room, so I'm going to go up here. So in my calculator, I'm going to type in this to see what I get for x. Be sure you're in radians. I got 1.96, that what you got? This is a tricky problem. Okay, so here's my picture. I want cosine to be negative. Where is x negative at? It's this v right here. You'll see it? You look there to the side before you get your answer. Because I had -8/3, which is -3/8. You see it? You look here. Now, guys, if this is radians, this is 3.14. So 1.96 is actually the distance from here all the way to here. All this is 1.96. Right? So to find the other measurement, you want to start here and go to there. If I close the gap, I would be at 6.28. And I know this whole peak section is 1.96, so it's 6.28 minus 1.96, which is 4.32. That's a hard one. Number 10. Okay, I think we could all use more practice cues, right? So this is probably a really good one. Okay, start number 10. Am I going to shift it up and down any? No. Okay. Am I going to change my y's any? Yeah, I'm going to multiply my y's by -2. So what's it going to do? It's going to flip it, right? And what am I going to do with my x values? My pi over 2, my 3 pi over 2 pi. What am I going to multiply those by? 1/3. Okay, let's go ahead and do that right now because that's the hardest part for everybody. Okay, to find my total normally is 2 pi, correct? So I'm going to take 2 pi over 1 and multiply it by 1/3. Why 1/3? Because what do we do to it? We flip it. So now my new total is 2 pi over 3. That's not very big, is it? In other words, my entire graph is going to be from 0 to 2 pi over 3. But what that does is that gives me a total. But we have 4 hash marks, don't we? So how are we going to find the rest of the hash marks? What do we multiply it by? Do you remember? By 1/4. So to find the part, you found the total. Here's my total. To find the part, you take your total and you multiply it by 1/4. I'm going to break it into 4. So 2 pi over 3 for each section would be 1/4. So I have 2 pi over 12. Does that reduce to pi over what? Pi over 6. You can count by pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, right? So let's make our graph here. 4 marks. are we going to call those 4 marks? What is each part? Each part is pi over 6. I'm going to use a pencil so I can erase them and clean them up. So pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. But some of those reduce. 2 pi over 6 is the same as pi over 3. 3 pi over 6 is the same as pi over 2. 4 pi over 6 is the same as 2 pi over 3, which it should match. Look, my total is 2 pi over 3, my total is 2 pi over 3. Now that I'm multiplying my y's by -2, okay, I don't know if you remember, but my original cosine graph, cosine's the u, is your, and you should just already have that on your note card. That's your cosine, right? So for here, I'm normally at 1. Where am I going to be? This is my first stop. 1 times -2 is -2, right? So I'm down here now, at -2. Go to the next stop. I'm at 0. What's 0 times -2? It's still at 0. And my third stop on my regular graph is -1. -1 times -2 is +2. So you wait here at +2. The next stop is back to 0. 0 times 0 is still 0. And then back down. 1 times -2 is -2. Okay? So now then list a point. You can list this point, for example, that would be over pi over 3 and up 2. It's fine, any point. I'm going to skip around. I'm going to move to problem 20. Look at 20. Don't remember how to do this one? What do you do first? You plug in 4 into f. So you come over here, and you kick out x, and you put in 4. So instead of 3 minus x, I'm going to 3 minus 4, which is -1. Agree? So then that means this value is -1, so I want g of -1 now. So you go to g, and you kick out x, and you put in -1, which means I've got -1 plus 4, which is 3. How about 16? State if the function is even, odd, or neither. So we kick out x, and what do we put in its place to decide? -x. So the problem is going to look like this. Right? A negative cube stays negative. So I have a negative x, plus 1. Well, it stayed negative, so it turns to positive now because there's negative in front. So if you look, this changed, and the 1, in other words, this was negative, it turned positive, this is positive, it stayed positive. So what are we going to call that? Neither. Anybody else see one really quick you want me to do? I have time for like one more. Okay, look at 13. It won't be one quite this hard on the test, but if you choose to do it, you FOIL it. So I'm going to write cosecant x minus cotangent x. Then I go here, plus cosine x cosecant x. And then here, minus cosine x cotangent x. And then you just rewrite them. But when you rewrite them, you're going to clean up this multiplication and this multiplication first. All right, we're out of time.